Today's lesson is section 6.6, which we're going to discover and learn all about trapezoids and kites today. So we do have several definitions, so let's go ahead and get started. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. All right, so one pair of parallel sides. I'll go ahead and put a trapezoid over here. Now they could look a little bit different. That's what one could look like. And we will say these two sides are my parallel sides. We also have different kinds of trapezoids. All right, so the base of the trapezoid is the two parallel sides. So there's actually two bases. Okay, so I'm going to write base up top. I'm going to write base at the bottom. All right, the base angles of a trapezoid. They are the two angles formed by one base and the legs. All right, so we could say that the base angles will go with these two, okay? We're gonna find out some information about all of these here in a little bit. So the legs of the trapezoid are the non-parallel sides. An isosceles trapezoid is a trapezoid with congruent legs. Which means their legs are going to be the same length. So if I were to make my trapezoid to the left an isosceles trapezoid, I would put those line segments through there, those dashes, to show that, hey, those two sides are the same length. All right, the mid segment of a trapezoid, sometimes it's also called the median. So we'll write that down. You need to be familiar with both. It is the segment that connects the midpoint of the legs of the trapezoid. So it connects the midpoint midpoints of the legs of the trapezoid. Okay, so that's a whole lot of information about trapezoids, and we just have one little definition about kites. So a kite is, again, it's a quadrilateral with exactly two distinct pairs of adjacent congruent sides. All right, so think about, let me see my best regular kite, because they have all shapes of kites now. There we go. So two distinct pairs of adjacent. So those two are adjacent and congruent. And these two down here are adjacent and congruent. So there's all our definitions. We're going to be using this information throughout today's lesson. So two quick theorems. I think there's just two. Oh, no, there's several more on the back. So it says, if a trapezoid is isosceles. Okay, so if we have an isosceles trapezoid, then each pair of base angles is congruent. Just like an isosceles triangle. So here it says angle A, if we're looking at this diagram, C is missing over here. Let me put in C. That's a bad C. All right, there's C. So angle A is going to be congruent to angle B, and angle C is going to be congruent to angle D. So an isosceles trapezoid, which means I need to put some other segments in here. And all of a sudden, here we go. We need to put these two are parallel. All right, so I think that's all the information we need. I'm just gonna make those two look a little bit neater. All right, so that's our isosceles trapezoid. We had to show that the top and bottom were the bases, so that's how we put those two were parallel. If it's isosceles, A to D and B to C, those sides are going to be congruent. So then we know that angle A is congruent to angle B, and angle C is congruent to angle D. All right, so for this next one, before we get our definition, we're gonna go ahead and put that these two sides here are parallel. Good enough. Okay, so now let's fill out what we know. If a trapezoid has a pair of congruent base angles, so we'll say those two are my congruent. I need to write base angles in here. Then it's an isosceles trapezoid. So before it said if it's isosceles, then we know the base angles are congruent. However, this says if we have just one pair of congruent base angles, then we know it's an isosceles trapezoid. Okay, so quadrilateral ABCD is an isosceles trapezoid. All right, so let's move on. Our next theorem says a trapezoid is isosceles if and only if its diagonals are congruent. So now we know, and I'm going to put in black the information. So we know it's an isosceles trapezoid, so I need to know which two sides are parallel, which two sides are congruent. All right, so that's telling me that it's an isosceles trapezoid. Then we know that the diagonals are congruent. All right, see how straight I can make this. Not very straight, but that's okay. So we know that line AC, or that segment, is congruent to segment BD. And last but not least, our theorem for today, and actually it's not our last, we have a couple on kites then, is our mid-segment theorem. Okay, so the mid-segment of a trapezoid is parallel to each base, and it's half the length of the sum of the bases. So very similar to that of a triangle. All right, so we are going to put that these two are parallel. Okay. All right, and everything else I think we're going to do. So the mid-segment of a trapezoid. So the mid-segment, that means M cuts BA equally in half, and that N cuts CD in half. All right, so I think that's all the information we need. So if MN is parallel to AD, and MN is parallel to BC, then we know that MN is half the sum of AD and BC. So now I'm also going to put that that one is parallel. Okay, so the midpoint or the mid segment is parallel to both bases, and its length is equal to half of the sum of those two bases. All right, so example 1. It says WXYZ is an isosceles trapezoid. We have to find the measure of angle X, angle Y, and angle Z. So if it's an isosceles trapezoid, we know these two are parallel. We know those two sides are congruent. We know those two bottom angles are congruent, and the top two angles are congruent. All right, so that helps me because if angle W is 110 degrees, it's equal to angle X. So we can say the measure of angle X is equal to 110 degrees. So that's one. Now, to get the other two, we have to think. All quadrilaterals add up to 360. There's a couple ways we can think about it. So if they add up to 360, I could take 360 minus 110, take that answer and divide it by 2. The other way to think about it is since these two lines are parallel, that's the transversal. We know, let me get a different color, that this angle and that angle are supplementary. So to get the last one, to get Z, we could say the measure of angle Z is equal to 180 minus 110. So we know the measure of angle Z is equal to 70 degrees. And we know that Z and Y are the same, so we can say the measure of angle Y is also 70 degrees. And there we found everything we needed. Right, example 2. Find the length of the mid-segment MN. Well, we know the mid-segment, which in this case is MN, is equal to 1/2 PQ plus SR. So let's substitute in what we know. So MN, we don't know that, so I'm going to keep that MN. Sometimes they might give us that. Is equal to 1/2 PQ is 10, SR is 16, so 1/2 of 26. So therefore we know that MN is 13 units long, whatever those units may be. All right, so you have a couple your turns to try. So go ahead, pause the video, try those, come back and check your work. right, so for this one, it's still a quadrilateral, so we know it's all 360. So 360 minus 90 minus 90 minus 62. When we go through, do all of that work, we get 118. Could have also done 180 minus 62, and that also would have given us 118. We have to be careful. We can't say that those two add up to 180 because those two lines aren't parallel. We would have to use these two parallel lines cut by the transversal. Okay? All right, so just a couple more things. I know these notes are pretty long today. So theorem 6.8, we have things about kites now. So if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so the diagonals are perpendicular. So we know that B to D is perpendicular to A to C. Okay. Some things I'm noticing. I think they're on your paper. I don't think I drew them in, but I may have. We have those. And this one down here has that. All right. So we can say that, and remember, all I have to do is put one little perpendicular mark in there. Second one says, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Okay, only one pair. It has 4 angles. One pair would be 2, another pair would be the other 2. So that means AC is congruent, or sorry, angle A is congruent to angle C, and angle B is not congruent to angle D. So I will put A and C. And if you think about it, B is larger than D if you look at them. All right, last couple problems to finish out chapter 6. Our third example, it says JKLM is a kite. What is the measure of angle J? All right, so again, a kite is a quadrilateral. A quadrilateral adds up to 360. So we would do the measure of angle J plus the measure of angle K plus the measure of angle L plus the measure of angle M is equal to 360. So J I don't know, so I'll call that X. K is 150. L we don't know, but since K and M are different, that must mean J and L are congruent. So we can call that X again, plus M, which is 70, and that is equal to 360. So combining like terms, we're going to get 2X plus 220 is equal to 360. 2X is going to equal 140. And X is going to be 70 degrees. Trust me, I know those two do not look the same as M, but that's how it works out. All right, so take a moment, try the your turns. Don't forget for that last your turn, number 6, to look at that very last theorem we talked about. All right, this last one's going to take us to think a little bit. So we know that Q to T and T to S, they're the same. P to T is 4. T to R is 1. We have to find X though. So one thing we have to remember is that the diagonals of a kite are perpendicular. Okay, so I'm going to pull out something here. I'm going to pull out that triangle. I will highlight the triangle I just pulled out. And some of you are looking at this and you're like, oh, I know the answer already. And if not, that is 100% fine. So we have our triangle, lovely triangles. So it is a right triangle, so we can use Pythagorean theorem. If you remember this, you know the answer already. I'm going to go through, do Pythagorean theorem, just in case it's not quite clear to you yet. So we know that x should equal 5. 1, because remember that's the Pythagorean triple, 3, 4, 5 triangle. So x is 5.